This code imports various libraries for data manipulation and analysis, such as pandas, NumPy, and matplotlib. It also imports functions and classes from the Zipline library, which is used for backtesting trading strategies. The code defines a pipeline, which is a way to calculate and access data for multiple assets at once. It also sets up the trading environment and specifies rules for when and how trades can be made. Finally, the code imports PyFolio, which is used for performance analysis and visualization of trading strategies. This code begins by ignoring any warning messages that may occur during the execution of the code. It then sets the random seed to a specific value, 42. Setting the random seed will ensure that the results of any random processes in the code are reproducible. This code is loading default extensions for the long-short strategy backtesting using Zipline. The load_extensions function is being called with three parameters: default set to true, extension set to an empty list, and strict set to true. This function is responsible for loading the required extensions for the strategy, ensuring that the loading process is strict and using the default environment for the strategy. This code sets up logging for a long-short strategy backtesting process using Zipline. The first line creates a log handler that formats the log messages with a specified format string. The log handler is set to only log messages with a level of warning or higher. The second line pushes the log handler to the application, which means that any log messages triggered after this point will be handled by this log handler. The third line creates a logger object named algorithm, which will be used to log messages related to the algorithm being tested. This code sets the values for three variables in a long-short strategy backtesting program. The variable n_longs is set to 25, indicating that the program will place up to 25 long positions. Similarly, the variable n_shorts is also set to 25, indicating that the program will place up to 25 short positions. Finally, the min_positions variable is set to 20, indicating that a minimum of 20 positions must be placed for the backtest to be considered valid. This code loads the quantile bundle data for backtesting a long-short strategy using Zipline. This code function, load_predictions, loads prediction data from a file and performs some data manipulation. First, it reads prediction data from two different HDF files, one for training data and one for testing data. It appends the testing data to the training data and drops the y_test column. Next, it removes any duplicate rows based on the index and keeps only the first 10 columns. It calculates the mean of each row and sorts them by index. Any rows with missing values are then dropped. The resulting data is stored in a data frame with the column name prediction. Then, it gets the unique symbols from the index of the predictions data frame and uses them to look up the corresponding assets from a bundle using the lookup_symbols method. The resulting assets are stored in a variable. The code then creates a mapping between the symbols and their corresponding security IDs, SIDs, using a dictionary. Finally, the code unstacks the symbols to create columns of predictions, renames the columns using the ticker SID mapping, selects only the prediction column, converts the time zone to UTC, and returns the predictions data frame along with the assets. This code initializes two variables, predictions and assets. It uses the function load_predictions, which takes in the argument bundle_data to load data for predictions and assets. The specific details of the function and what data it loads are not provided in the code. The code you provided is simply asking for information about the data stored in the variable predictions. It is using the info function to retrieve details such as the number of entries, column names, and data types. This information can help in understanding the structure and content of the dataset, which can be useful for further analysis or processing. This code defines a class called signal data that is a subclass of dataset. It has two attributes, predictions which is a column of floating point numbers, and domain which is set to US_equities. This code is likely used in a long-short strategy for backtesting using Zipline, a Python library for algorithmic trading. It seems to be responsible for storing and handling signal data for a certain domain, possibly related to stock prices or market indicators. This code initializes a signal loader object, which is a dictionary used for loading signal data for backtesting a long-short strategy. The signal loader object has a key called signalData.predictions and a value that is a data frame loader object. The data frame loader object is used to load the actual signal data, which in this case is stored in a variable called predictions. This code defines a class called MLSignal that inherits from custom factor. It is used to convert signals into a factor, allowing for ranking and filtering in a backtesting strategy. The input to the class is the predictions from a dataset called signal data. The class has a window length of 1, meaning it only considers the most recent prediction. The compute method within the class assigns the predictions to the out variable, which is the final result. This code defines a function called compute_signals that is used to calculate trading signals for a long-short strategy. It creates an instance of a class called MLSignal and assigns it to a variable called signals. The function then returns a pipeline object that has two columns, longs and shorts. The longs column contains the top n_long signals from the signals object that are greater than 0, while the shorts column contains the bottom n_short signals that are less than 0. The pipeline object is filtered by a static list of assets defined in the assets variable. This code is part of a long-short strategy for backtesting with Zipline. In the initialize function, various context variables are defined, such as the number of longs and shorts positions, the minimum positions required, the universe of assets, and trade data collected. Slippage and commission settings are also set. Two functions are scheduled to be called at specific times. The rebalance function is called every day at market open, and the record_vars function is called every day at market close. Lastly, a pipeline for computing signals is created and attached to the algorithm. This code is a function that is called every day before the market opens. It takes some data as input and performs some calculations. First, it retrieves the output from a pipeline called signals and assigns it to a variable called output. Then, it creates a new data frame, df, by appending the longs column from output as integers and the shorts column from output as integers multiplied by -1. Next, it separates the data frame into two parts, holdings and other. Holdings contains the rows where the values are not equal to 0, and other contains the rows where the values are equal to 0. After that, it removes any duplicate rows from other and ensures that other does not contain any rows that are already present in holdings. Finally, it assigns the combined data from holdings and other to a variable called context.trades and checks if the number of unique indices in context.trades is equal to the length of context.trades. This code is a part of a long-short strategy backtesting using Zipline. The rebalance function is responsible for executing orders based on a scheduled function. First, it cancels any open orders using the get_open_orders and cancel_order functions. Then, it retrieves the current positions in the portfolio and calculates the value of each position. It iterates through the trades in the context and checks if the trade is equal to 0. If it is, it places an order to target a position of 0 for that stock. Otherwise, it adds the stock to the respective trade list in the trades dictionary. Next, it determines the number of long positions and short positions based on the length of the trade lists. If there are enough long and short positions, it places orders to target a specific percentage for each stock in the trade lists. If there are not enough long and short positions, it places orders to target a position of 0 for each stock in the trade lists. This code defines a function called record_vars that is used to plot variables at the end of each day in a backtesting strategy. The leverage variable represents the leverage of the account, while longs and shorts represent the number of long and short positions in the strategy. The record function is used to record these variables for analysis and visualization. This code assigns the values of the date column in the predictions data frame to the variable dates. The dates variable will then be used to determine the start date and end date of the dataset by calculating the minimum and maximum values in the dates variable. This code prints the start and end dates of a given time period. It uses the format method to display the dates in a specific format. This code measures the duration of the execution of a long-short strategy backtesting using Zipline. The time function is used to get the start time before running the algorithm. The run_algorithm function runs the backtesting, taking various parameters such as start and end dates, initialization function, pre-trading start function, capital base, data frequency, bundle, and custom loader. The print statement shows the duration of the execution in seconds by subtracting the start time from the current time. This code extracts returns, positions, and transactions from a backtesting using Zipline. The Zipline library is commonly used for backtesting trading strategies. The function extract_rets_pos_dxn_ from _Zipline retrieves the returns, positions, and transactions from the backtesting results and assigns them to respective variables named returns, positions, and transactions. These variables can then be further analyzed or used for other purposes within the code. This code fetches the historical data for the S&P 500 index from 2014 to 2018 using the web.dataReader function. It then calculates the percentage change in the index value and converts the time zone to UTC. The resulting data is stored as the benchmark variable. This code is creating a figure with two subplots using matplotlib. In the first subplot, it is plotting the rolling returns of a strategy along with the returns of a benchmark. It also includes a cone around the returns to show the uncertainty in the forecast. The plot is set to not use a logarithmic scale, and the legend is placed in the best location on the plot. The second subplot plots the rolling Sharpe ratio of the strategy. The titles of the subplots are set, and the figure is arranged to fit properly.